Hi everyone, my topic today is C++17 parallel algorithm. So before we want to step into the parallel algorithms, let's first quickly talk about what C++ is and why we want to talk about version 17. So C++ is a free programming language that was designed by Beyond Straubschop. It is towards on system programming and focusing on performance and efficiency. It was initially named as C with classes. It was built as a more flexible version of C language, but with the OOP concept. It was renamed in C++ in 1983. After that, two commercial version has released until October 1998. The first ISO standard of C++ was released. This allowed the compiler could be built from different vendors and built on different platforms. Then C++03 is released 5 years later as a bug fix version, while later in 2011, C++11 is released as a major version of C++ standard. This version expanded the core language feature tremendously, add many essential features such as lambda, auto-type assertion, and it also made some important add-ons in the standard library like thread support and reg expression. We would all be familiar with many features such as the chrono timer, long data type. Those features we all have used in this unit all come from this version of C++ standard. So benefit from those significant changes, many of the hardware acceleration library are supporting C++ since version 11. For example, CUDA, OpenCL, Microsoft, AMP. Well, comparing to the major changes in C++11, the version 14 released in 2014 is more like a patch update. It improved some features that were added in version 11. Later we have come to the version 17 family, and it is the last version of C++ standard. It updated many language features and most importantly bring many new things into the standard library. For example, many special mathematical functions, file system library, and the library we're going to use for our demonstration today, a parallel version of STL. We want to explain that later. So lastly, C++20 is the upcoming major version of C++. It could be a very exciting version like version 11. New features added such as concept and module. I think those should help the language grow for one more time. Before we want to talk about the parallel version of STL in C++17. So I'll first introduce what is STL. So STL stands for Standard Template Library. It is a set of templates built in C++ that provides many data structure and algorithms, and it consists of 4 parts: algorithm, container, function, and iterators. The containers here, I think it just means data structures. We can see those things are all very essential things in programming. Now let's get familiar with STL using a code example with matrix multiply. Well, before this, I want to say this is probably not a very good example of showing how STL will make things better. Our code will have very simple logic. Implementing STL, I think, could make it much more complex and slow down performance speed. But I think it's a good case just showing how STL looks like and have a comparison between the parallel version of STL. So I have wrote 3 code example here to show how this will work. So the environment is in MSVC, Microsoft C++ environment, and let's go to the first. The first code is the sequential version of a matrix multiply. It multiplies two matrix with the size of n times n, and we have defined the n to 500 in this case, and we have set the same random seed to initialize the value in the all three code demo. So here we can see it's just a three simple for loops, and we all seen this in this unit before, and it's nothing to talk about. We will run this code for n times, which we have already defined as 10 for all three demos, and we will run this code. It will show the average time of the 10 times result. Yeah, so we got the result here saying the average time is 0.3 seconds almost. So in the code demo 2, we also want to change the n as 500 and using same seed. So we can see here is the STL version of for loop, and it's a for each loop, and not using index, and instead using iterators, and it looks quite complex, and also that doesn't really help our current code at all. But we can see how this for loops looks like in STL library, but it could definitely help with code with much more complexity. Well, we ran this code and we get the average result of 0.38, so it is even slower than the previous version. So that what I mean, it couldn't help with our code scenario, because it's passing much more arguments compared to the previous simple for loop, and which could slow down our performance. So that's just how for each loop looks like, and there's much more things like vector we can use, but for our scenario we don't need it at all. So the parallel version of STL requires C++ version 17. We have to substitute that to the compiler. So this third code demo is using parallel version of STL. So just by observing, we can see it's almost same code, but just add this STD execution part. So that is how simple you switch to a parallel version of STL. You just add a thing called execution policy, and that will simply make the code parallel. And we also want to change the n to 500. Let's run this to see how it gets faster. Yeah, we can see the result of is 0.06. That helps with performance tremendously. So yeah, that's how simple you can get things to parallel with STL library in C++ 17. Don't forget about the sorting algorithms that, for example, provided in STL library. We can all get those things parallel easily. And we can imagine how hard it is for programmers to write a parallel for loops, for example, using thread before C++11. This is an example I found on the internet. So C++17 provides three execution policies. So we can choose either of them, and this makes programming in parallel very safe, and it won't cause any deadlock. Well, lastly, I want to mention about one of the competitor I consider to C++. So in parallel programming, I think Rust as a programming language is getting much more popular. So it have very big community support. You can easily achieve some complex parallelism just using libraries, and most importantly, I think those libraries are all can be guaranteed with thread security. I think that's part of a big advantage compared to C++. You don't have to put too much consideration into details and get acceptable performance. Thank you. That's my presentation.